Hello, everyone. We are going to continue our study of trigonometry with section 7.2, angles and the unit circle. And we're going to be in this section, as you can see by the objectives on the top, we're going to be understanding and applying a new unit that we haven't used before called a radian, and we'll be converting from degrees to radians to measure angles. We're going to be learning how to draw angles in standard position on the coordinate plane. We're going to identify angles on the unit circle, and we're going to be learning also about coterminal angles and reference angles. Okay, so in order to do this, first we're going to do a little bit of review. In section 7.1, we were looking at SOHCAHTOA, which focused on acute angles in right triangles. And we're going to continue now, and we're going to be looking at all the angles around a circle. So we're going to be looking at angles that are positive and larger than 180 degrees, up through 360 degrees if we go out one full circle, or more than that. So for the first time, you're going to be talking about rotating around a circle more than once at a higher number than 360 degrees. And also we're going to be looking at rotating around a circle in the opposite direction and getting negative angles. Okay, so first of all, I want to review what you would have known from past experience. We know that acute angles are angles that are greater than 0 degrees, right? In other words, we're not talking about negative angles here, and less than 90. Okay, and just to kind of give you a visual looking something like this, this would be an example of an acute angle, right? A right angle we know is exactly 90 degrees. It's typically labeled with a box to form the angle. An obtuse angle we know is an angle that is greater than 90 degrees and less than 180. Okay, so it looks like something like this. And finally, a straight angle would be a 180-degree angle. Okay. So since we're going to be looking at rotating around a circle, it's going to be important to recall what the formula is for the circumference of a circle. And remember, the circumference of a circle is the distance around a circle. Okay, in other words, how many linear units are we traveling when we go around the circle? Okay. And you recall that in the past, you've either used circumference is equal to 2 pi times the radius, or since we know that there are 2 radii in a diameter, you know that circumference is equal to pi times the diameter. Okay. And of course, what that leads to is to note that if I wanted to solve for pi, we can remember that the value of pi, that constant, if we were to solve this equation for pi, we would get that pi is equal to the ratio of the circumference to the diameter in every circle. So in other words, we know pi is approximately 3.14, so we know that the distance around a circle is a little over 3 times the length of its diameter. Okay? Now, for a radian, let's define what a radian is. Okay? So a radian is, of course, a unit of measurement. Okay? And it is a unit that is used to measure the size of central angles. Okay? Now, what do we mean by a central angle? Well, let's draw an angle on this circle that we see over here for a moment. So I'm just going to highlight an angle here, and I'm going to put one side of the angle on the positive x-axis, And I'll just draw an acute angle to here, okay? And so when we're talking about a central angle, we're talking about an angle that has its vertex at the center of the circle, okay? So I'm going to call that angle theta, okay? So it's a central angle because it has its vertex at the center of the circle, and you probably remember that from geometry, okay? Okay, now 1 radian has an intercepted arc, okay? So let's look over here. When we look at this angle, there's an arc. You remember this from geometry, okay? There's an arc that angle intercepts. In other words, it intersects on the circle, okay? 1 radian's intercepted arc has a certain length, okay? Now, what you can imagine, and if you notice the root of the word radian shares the same root with the word radius. So 1 radian's intercepted arc, this length right here, is actually going to be the same length as the radius of the circle. Okay, it's going to be the same length here. Here's a radius of the circle. Here's a radius of the circle. And you remember from geometry, there's an infinite number of radii around the circle, all that have the same length. So that 1 radian's intercepted arc is equal to the length of the radius in a given circle. Okay, so let's look at this. Now, you may or may not have seen this in geometry. I teach it in geometry, but sometimes it's taught, sometimes it's not. So if you notice here, what I've done on this rubber band is I've marked off in red the length of the radius of the circle. Okay, now let's wrap that around the circle. Let's notice here that if I wrap right over that intercepted arc, that length along the circle is the same length as the radius, which means that theta has a measurement of 1 radian. Okay, if I continue around the circle, so I start there, I'm going to mark off again. Okay, so if I were to draw an angle here, I'm not going to draw another radius here, but if I were to draw another angle, it would have a measurement of 1 radian as well. And continuing again, you'll notice here, basically just a little bit, if I mark off right to about here, if you count, you can count 1, 2, 3, and just a little more radii lengths to this point on the circle, okay? Now, if I were to wrap around completely one halfway around the circle, I would actually have just a little over 3 radians, and if you'll notice, pi is that number, a little over 3. And so when we wrap 1 halfway around the circle, we have, of course, we all know traveled 180 degrees, but 180 degrees is also equal to pi radians, okay? And if I continue to travel around the circle, continue, and I've gone around 360 degrees, which of course that's also the 0 degree mark as well. So that's at 0 degrees, but if we wrap around, we've traveled 360. So 360 degrees, we've traveled 1 pi radian, and continuing around, we've now traveled 2 pi radians. Okay? So what we've learned now is that for conversion purposes, a half circle is equivalent to pi radians or 180 degrees. Okay, so it's basically conversion, just like if you're converting between like feet and miles or inches and centimeters. We're just converting between two units here. Okay, now we are going to be defining this circle as a unit circle. Okay, unit meaning coming kind of from the same word as uno, or in Spanish, for example, one. So basically what we're talking about here is a circle that has a radius of 1 unit. Okay, so how's that going to help us? Well, let's look at a full circle now. Looking at a full circle, we know that if we travel completely around that full circle, that circumference is 2 pi r. Okay, well, what we're going to do here, because this is a unit circle, we're going to let r equal 1. And as you can see here, the circumference comes out to 2 pi radians. Sometimes we'll abbreviate radians as RAD. Okay, and so we can see here that 2 pi radians equals 360 degrees. Okay, so before we move on to anything else, we're going to practice converting back and forth between degrees and radians. Okay, so in order to convert back and forth between degrees and radians, we're going to use conversion factors. Now, because we know that there are pi radians and 180 degrees, what we're going to do to go from degrees to radians is we're going to take the value in degrees and we're going to multiply by pi radians per 180 degrees. Okay, pi over 180. Okay, so 30 degrees. Very, very simple. To convert that to radians, multiplying by pi over 180. Just think of this as a multiplication of fractions example, okay? So if you were to want to multiply a whole number by a fraction, you would simply take that whole number, put it over 1, and then you could multiply horizontally and then simplify, or first cancel diagonally. I would argue that canceling diagonally is the most efficient. We know that 30 goes into 180 6 times. Then we just multiply horizontally. We get pi in the numerator. 1 times 6 is 6. So what we found is that 30 degrees is pi over 6 radians. And we can, as I said, abbreviate that RAD. Okay, as I said, we're going to be working with negative degrees. We'll be learning very shortly how wrapping around the circle, we can wrap around in a direction to give us negative degrees. Okay, so we can do the same here. We can continue, we can multiply by pi over 180. Okay, and if we are considering here, what to divide by to cancel the values out, you could do this step by step. You can think about what the largest value is that you can think of that would go both into 135 and 180, or do it, like I said, step by step. Okay, so I think, for most of us, you might be thinking to start with that you might start with 5, for example. Okay, so if we were to cancel, putting a 1 underneath, if I cancel and divide by 5, 180 divided by 5, well, 180 divided by 10 is 18, so 180 divided by 5 would be 36. Okay, if I divide 135 by 5, I believe that comes out to 27. So 5 times 2 is 10, remainder 3, 5 times 7 is 35. Okay? Now don't forget to carry that negative down. You don't want to lose the negative when you're writing your answer, because if you start out negative, of course, it has to stay negative, right? And then, of course, this is just simple arithmetic here, right? We know that in 27, we can divide by 9. 36, we can divide by 9. So 27 divided by 9 is 3, and 36 divided by 9 is 4, right? So we end up with negative 3 pi over 1 times 4 is 4, negative 3 pi over 4 radians, okay? And another way to look at that is 3/4 of pi, right? So negative 3/4 pi. Same thing over here. You could think of this as 1/6 of pi. And that makes sense if you think about this logically, right? 1/6 of 180 is 30. And therefore, you're at 1/6 of the way across the circle. And pi is halfway across the circle, and this is 1/6 of the way. Okay, so think of these as just fractional values of pi. Now this one, we shouldn't have to do much, right? We already know pi is the same as 180 degrees, but just to verify it, watch. Pi times pi over 180, and sure enough, if we cancel, we just get pi radians. So you can see how this conversion factor works. Okay? All right, let's do another conversion. This time we're going to work backwards and we're going to go from radians to degrees. Okay, so we're going to multiply by 180 degrees over pi radians to be able to convert from radians to degrees. Okay, so we'll start out here with pi over 3 radians. So we've got pi over 3. And we'll multiply by 180 degrees over pi. And by the way, you can, if you're trying to remember which to use for which direction, you'll see it's obvious here what you want when you're going from radians to degrees. You want pi to cancel. And if you accidentally multiplied by pi over 180, you would not be able to cancel pi. So you know the pi needs to go in the denominator to be able to cancel radians. Okay? So we'll cancel pi here, and then just multiplying across. In the numerator, we'll get 180. In the denominator, we'll get 3. And so we can see that pi over 3 radians is equivalent to 60 degrees. Okay, and by the way, these are going to be very, very useful very shortly. We're going to be looking at knowing equivalent values on the unit circle, converting from radians to degrees and back and forth. 30 degrees and pi over 6 and pi over 3 and 60 are just conversions that you're just going to know off the top of your head. Okay? All right, so let's look at negative 5 pi over 3 radians. So we've got negative 5 pi over 3. We're going to multiply by 180 over pi. Okay? Again, I suggest canceling diagonally. Especially right here, of course, pi is going to cancel. And cancel diagonally here. 3 goes into 180 60 times. Now we've canceled all out of the denominator. We can just multiply the numerator across, and we can see that negative 5 times 60 gives us negative 300 degrees. Okay? And again, we already know what 2 pi radians are. 2 pi radians we've already determined is 360 degrees, but as you'll notice, let's just confirm it with our conversion. So we've got 2 pi times 180 degrees over pi. And again, if you'd like, put this over 1, cancel diagonally and multiply horizontally, and sure enough, 2 times 180 gives us 360 degrees. Okay, so what we've done here on this page is convert back and forth between degrees and radians. Okay, and we will continue by looking at how to draw angles in standard position. Okay, and that will be, okay, so let's define what an angle in standard position will look like. Okay, so again, we're talking about drawing angles on the coordinate plane, which in geometry, you weren't necessarily used to that, but that's what we're going to be focusing on here in trigonometry. All right, so what we're going to have are angles with the vertex at the origin. Okay, we're going to have the angle starting at a certain point. And when we start, we talk about it being the initial starting point, or the, like when you would talk about, for example, a y-intercept being the initial value, the value at the beginning. Okay, so the initial side of the angle, where we're going to start the angle, the initial side of the angle is going to be on the positive x-axis. Okay? And remember, the angles are formed by two rays that meet at a common vertex, right? So the other ray that forms the angle is called the terminal side. Okay? So what we're going to be looking at here on these two coordinate planes, we're going to be looking at what an angle is going to look like when we draw a positive angle and when we draw a negative angle. Okay? With positive angles, we're going to be rotating counterclockwise. So we're going to have counterclockwise rotation. Okay? With negative angles, we're going to be dealing with clockwise rotation. Okay? So, for example, let's say that we have one ray of an angle here. This is going to be the initial side of the angle because it's going to be on the positive x-axis. So we call this the initial side. Okay? Now, for the moment, we'll just look at the angle as if it's in the first quadrant here. Here's going to be the other side of the angle, and we're going to call this the terminal side. Terminal meaning where it ends, right? Terminates. So there's the terminal side of the angle. And we talked about it rotating counterclockwise. So imagine the angles here. We'll call it theta. Starting at the initial side, when we rotate, we're going to draw the arrow on the angle. We're going to draw a curve for the rotation. Okay, so it's rotating counterclockwise. And as you can see, we have the vertex is at the origin at 0, 0. Okay. We can also rotate to create a negative angle. Again, the initial side of the angle will be on the positive x-axis. Okay. Rotating clockwise, here's a terminal side of the angle. Here's the angle theta. And we're going to rotate in a clockwise direction, and we'll have the vertex at 0, 0. Okay, so those would be examples of angles in standard position with no specific degree or radian measure. Okay, but on this page, what we're going to do is we're going to draw angles in standard position in both degrees and radians with specific values. Okay, now we are not measuring these values using a protractor like you might have done in geometry. We are going to use the axes and the values, the number of degrees and radians on the axes to be able to estimate where these terminal sides are going to go. Okay, so let's see how we do this. First thing you want to do when you're drawing angles in standard position, if you're dealing with degrees, you want to label the axes in degrees. Okay, if you're dealing with positive measurements, you're going to label the axes in positive degrees. If you're dealing with a negative measurement, you're going to label the axes with negative degrees. Okay, so I'm going to name this spot here on the positive x-axis as 0 degrees, and also if I drew one full rotation, that would be 360 degrees. Okay, so 0, 360. Now if I'm rotating in the positive direction counterclockwise, at this point obviously I would get to 90 degrees, right? Because I know that I've got a right angle here. Okay, I'm not going to draw that in, but we know that's a right angle. If I continue halfway around the circle, I'm at 180 degrees. Continuing another 90, I'm at 270, and finally completely around, I'm at 360. Okay, so we can estimate that halfway between 0 and 90 is 45 degrees, and so I would draw the terminal side of the angle, and I would draw, always want to draw the rotation. Okay, so that rotation here represents theta equals 45 degrees. Okay, and that is all there is to the process of drawing an angle in standard position. Okay, let's look at a larger measurement, 225 degrees. Okay, so if we were to draw an angle at a 225 degree angle, again, I want to label 0 degrees, 360, 90, 180, 270. Okay, now to figure out where 225 is, imagine, you know, you're going around the circle in a counterclockwise direction. You know that 225 is between 180 and 270. And if you're not sure exactly where, what you can do is take the difference between 225 and 180. So watch, if I do 225 minus 180, I get a difference of 45 degrees. Okay, so what that tells me is that when I'm traveling around the circle, I'm rotating, I'm going to stop halfway between 180 and 270. That'll give me a 225 degree angle. Okay, so my terminal side is going to be right here. And what I can say is I've drawn theta is equal to 225 degrees. Okay, so let me just get rid of this. Okay, so we can see that you should notice the terminal side. I'm just going to highlight that here. So in each of these cases here, we've drawn an angle, and things to notice are that, you know, here, this is an acute angle that we're used to. This angle, though, is the first time you're really seeing an angle drawn that's greater than 180 degrees, greater than a straight angle. So we're looking at this measurement here, not this measurement here, okay? But let's look at this one at negative 135 and see what we get with that. So notice, for example, this is negative. So with that negative 135 degrees, I'm going to label 0 degrees, but I'm going to label this negative 360, and I'm going to start labeling going clockwise around. So if I were to travel clockwise around the coordinate plane in a circle, here I'd be at negative 90, here I'd be at negative 180, and here I'd be at negative 270. Okay, so you should notice here that negative 90 degrees is equivalent to 270 degrees as far as where the terminal side of the angle would be. Okay? Now, if I want to draw negative 135 degrees, I know that negative 135 is between negative 90 and negative 180. Okay? And if I'm not sure exactly where or how far I need to travel, I can do a little subtraction. Now, ignoring the negatives, if I just say 135 minus 90, I know that basically I'm traveling another 45 degrees in absolute value beyond negative 90 to get to the terminal side of this angle. Okay, so that negative 45, or that angle here, is going to be 45 degrees farther as we wrap around the circle clockwise from negative 90. Okay, so if I were to draw that rotation here, I've now drawn an angle, theta, of negative 135 degrees. Here's the initial side of the angle. Here is the terminal side of the angle. Okay? Now, something to notice here, and this is going to be addressed shortly, is that notice that these two angles here have different values. One's negative 135, one's 225, and yet they have the same terminal side. Okay, the same terminal side. Very shortly, we're going to be defining that. These angles, because they share, co is a prefix that means share. They share the same terminal side. We call them coterminal angles because they share same terminal side. In other words, the same ending spot when you rotate. Okay? Another thing to notice is if you look at this rotation and you look at this rotation, if you were to put them together on the same coordinate plane, you'd have one full rotation around the circle of 360 degrees. Okay? So this is something to notice because I know that it comes up on your assignment. Okay? That if I were to take 225 degrees here and add in the absolute value of the negative measurement, okay, put those two together, 225 plus 135, sure enough, I get 360 degrees. Okay, so if you take a positive and a negative angle that are coterminal, that share the same terminal side, and we add the positive to the absolute value of the negative, you will get 360 degrees. Okay? All right, let's look at drawing angles in standard position using radians. Okay? So what I'm going to do is I'm going to label the axes using radians now to help me out. Okay, so I know that this is 0, and also if I wrap completely around the circle, I'm at 2 pi radians. I know that halfway across the circle is pi radians. Okay, so thinking logically, right, if I'm going halfway across the circle, half of that distance would be half of pi. So when I go 90 degrees, another way of representing that is 1/2 of pi, or pi over 2 radians. Okay? Continuing around the circle, traveling halfway between pi and 2 pi is 1/2 pi, right? But normally we don't say 1/2 pi, we say 3 pi over 2. That's typically how it's written. 3 halves is the same as 1/2, right? So typically we would say 3 pi over 2 radians. Okay? So if I want to draw pi over 4, understand that that's the same as saying 1/4 of pi. So what I'm doing is I'm traveling in a positive direction 1/4 of the way across to pi, which means halfway to 1/2 of pi, right? 1/2 of 1/2 is 1/4. So don't get, too confused with these radian measurements because you're really just using fractional values. Just think of these as fractions. Pi over 4 is 1/4 of pi, so it's 1/4 of the weight of pi. And so we'll draw that rotation in, and we will label it theta equals pi over 4. Okay? Now, some people, what they prefer to do when they're first learning this is they prefer to convert radians to degrees before drawing. However, that takes extra time, and to me it makes more sense to just label the axes in terms of pi, and if you just think of that as a fraction of pi, then you should be all set. Okay? So let's look at this one. Again, we have a positive value, so we're going to label the axes in terms of positive values of pi. So we've got 0 and 2 pi, pi over 2, pi, 3 pi over 2. Okay? So this is 5/4 pi. Well, think of that in terms of a fraction, right? So 5/4 of pi, this is the same as 5/4 of pi. Whether you say 5 pi over 4 or 5/4 of pi, same thing, which is just 1 1/4 pi, right? So what we're saying is we're traveling 1 pi plus 1/4 of pi. So if we think about that logically, pi plus 1/4 of the way across would be right here. So here we have our measurement. Theta equals 5 pi over 4. Okay? Now what you'll notice is, see this terminal side? Look at B and C up here. And you'll notice that 5 pi over 4 radians is equivalent to 225 degrees. Okay? And shortly we're going to be labeling the unit circle, and you'll see that relationship, that 5 pi over 4 radians is the same as 225 degrees, and of course in the negative direction is the same as negative 135 degrees. Okay? All right, so let's look at 2 more, and then I suggest that you pause and you look back at what we've learned and make sure you've absorbed it, and then we're going to look at labeling a unit circle in radians and degrees. Okay, so here we've got negative radians. So I'm going to do what I did before with negative degrees, and going in a clockwise direction, I'm going to label negative. So we know this is 0 and negative 2 pi. Wrapping halfway around, we'd be at negative pi. And half of the distance to pi would be 1/2 of pi, or pi over 2. But it's negative direction. And halfway between 1 and 2 is 1/2, or 3/2. So negative 3/2 pi, or negative 3 pi over 2. You know, and you'll notice, so this is just basically upside down of what we had up here, right? It's just in the negative direction. So pi over 2 on top, negative pi over 2 on the bottom, for example. Okay, so if we want negative 3/4 of pi, all we're doing is traveling 3/4 of the way to pi. So basically here would be the terminal side of the angle, traveling 3/4 of the way. There we go. So we've got theta equals negative 3 pi over 4. Okay. And then one more, and I suggest that you take a short break, make sure that you've absorbed everything. 9/4. Okay, so this is 9 pi over 4. 9 pi over 4 is 9/4 of pi, which is 2 1/4 pi, right? So basically we know, first of all, this is positive, so we're going to say 0, 2 pi, pi over 2, pi, 3 pi over 2, okay? So notice that this is more than 2 pi, right? 2 1/4 pi. So we actually have to rotate 1 complete circle around, plus another 1/4 of the way across to pi. So if I rotate 1 complete circle around in the counterclockwise direction, because it's positive, and then I'm going to stop 1/4 of the way over to pi. Okay? And we can say that this is theta is equal to 9 pi over 4. Okay? So a couple things I want you to notice here. Notice that first of all, remember we talked about common values that we should be familiar with. Like we already saw, if we flip back a page here, that pi over 6 is equivalent to 30 degrees. Pi over 6 radians is 30 degrees. Pi over 3 radians, 60 degrees. Okay? Check this out over here. You notice how these two terminal sides were in the identical location. So we're going to notice here 45 degrees and pi over 4 radians are the same. Okay? So pi over 4 is the same as 45 degrees. Pi over 4 radians, 45 degrees. Okay, also, in terms of radians here, notice the diagrams that we ended up with here. Okay, you notice how I said that these two were coterminal angles? Well, notice, okay? We already talked about here, I believe, that you notice this is the same position as negative 135, 225. So 225 is the same as 5 pi over 4. But in terms of radians here also, notice that negative 3 pi over 4 is the same as 5 pi over 4, right? So if we could do the same thing that we did up here. You notice when we added together a positive and a negative and we came up to 360 as long as we took the absolute value of the negative. So we could do the same thing here. Okay, these are coterminal angles as well. If we were to take 5 pi over 4 and add in the absolute value of negative 3 pi over 4, we would get 5 pi over 4 plus 3 pi over 4, which is 8 pi over 4, or 2 pi. And 2 pi is the same as 360. So it works the same with radians. If you have a positive radian measure and a negative radian measure, and you add in the positive with the absolute value of the negative, you're going to get 2 pi. Okay? Another piece to notice here, it would work the same way here. These two angles right here are coterminal angles. Now they're both positive here, so I'm not going to do the same thing where I, add and get 2 pi, right? If I add 9 pi over 4 and 1 pi over 4, I'm not going to get 8 pi over 4. But if I were to subtract 9 pi over 4 minus pi over 4, I'd get 8 pi over 4, 2 pi. Okay? So these two angles are coterminal angles. So you can have angles that are positive, both positive, or one positive and one negative, and they would also be considered coterminal angles as long as they have the same terminal side. And we'll be talking about more of that in a moment after we label a unit circle. Okay, so we're going to look now at the entire unit circle, and we're going to label it with degree and radian measurements. Okay, so first of all, remember, given that this is the unit circle, okay, you want to remember that we're always talking about terms of the vertices of these angles being at the origin. Okay, so right here is 0, 0. Okay, and remember that each of these lines is a radius. So we're talking about these angles having their rays intersect the unit circle, and we're going to be learning about the coordinates that represent those points of intersection. Okay, now for right now in this section, in section 7.2, I'm just going to look at the coordinates of what I call the corner angles at 0, 90, 180, 270, 360. Okay, but later on in section 7.3, we're going to be looking closely at the coordinates of the acute angles that are within, the space between the corners. In other words, at 30, 45, and 60 degrees, and their multiples. Okay, so we know that the radius here is going to equal 1 unit. Okay, so if we were going to look at this in terms of coordinates, if this is 0, 0, moving over 1 unit to the right, this point here is going to be at 1, 0. Okay, going up to here, this point, we know, of course, all of these are radii. Okay, so you've got all these are radii all around the circle. I can highlight all of these if I wanted to. All of them are radii equal 1, radius equal 1, radius equal 1. I could keep going all the way around. Okay, so here we've got 0, 1. Okay, over here we are at -1, 0. And over here, we're going to be at 0, -1. Okay? So let's first of all label the degree measurements here. Okay, we'll start with degrees and then afterwards we're going to work with radians. So starting here, we have 0 degrees, which is also, when I wrap completely around the circle, will be equivalent to 360 degrees. Okay? Rotating, we're going to look at this, when we label this, we're going to label it in the positive direction, not negative. So we wrap around 1/4 of the way around the circle, and we're at 90 degrees. Continuing halfway around the circle, we'll be at 180. Okay, 3/4 of the way around the circle, we'll be at 270. And here we're at 360. Okay. Now, halfway between 0 and 90, we're going to be at 45 degrees. Halfway between 90 and 180, if we recognize halfway is 45 degrees, if we add 90 plus 45, we'll get 135 degrees. Adding 180 and 45, we'll get 225 degrees. And adding 270 and 45, we will get 315 degrees. Okay? Let's do now multiples of 60 degrees. Okay? So here we've got 60 degrees right here. Now, if I add in another 60 degrees, I will land here at 120 degrees. Add in another 60, 120 and 60 make 180. 180 and 60 make 240. Okay. 240 and 60 make 300. 300 plus 60 make 360. Okay. Now let's add in multiples of 30 degrees. So we've got 30 degrees. We'll add in another 30 degrees. We'll be at 60. 60 and 30 make 90. 90 and 30, 120. 120 and 30, 150. 150 and 30, 180. 180 and 30, 210. 210 and 30, 240. And 30, 270. And 30, 300. And 30, 330. And add another 30, and we're back at 360. Okay? And to keep in mind, remember, we're rotating here counterclockwise because these are positive measurements. Okay? Now we're going to do the same thing with radians. Okay? So remember, at 0 radians, we're also considered 2 pi, right? So this is 0 degrees and also 0 radians. And 2 pi radians is the same as 360. Halfway across the circle, we're going to be at pi radians. We already know half of pi is pi over 2. Okay, let's move this up a little so we can see. And we already know that halfway between pi and 2 pi is 1.5 pi, or 3 pi over 2. Okay. All right, so now let's label 45 degrees and their multiples in terms of radians. Okay, so we know, we saw this already, that halfway between 1/2 and 0 is 1/4, right? So this is 1/4 of pi, or we say pi over 4. Okay, so now let's add 1/4 of pi on and continually add as we go around the circle. Right? So 1/4 and 1/4 is 1/2. 1/2 and 1/4 is 3/4. So another way to label 130 degrees is 3/4 pi, or 3 pi over 4. Okay? Add another 1/4, will be at 4/4, or 1 pi. Add another 1/4, will be at 5/4, or 5 pi over 4. Okay? Add another 1/4, will be at 6/4, but that simplifies to 3/2. Add another 1/4 and we'll be at 7/4, or 7 pi over 4. And then add another 4th, we're at 8/4, or 2 pi. Okay? Now we're going to do the same thing with multiples of 60 degrees. Okay? Now, we already saw that, and this is logical, right? That 60 is 1/3 of 180, right? So it's also going to be 1/3 of pi. And so 60 degrees is equivalent to 1/3 of pi, or pi over 3. Okay? Now, adding another 1/3 of pi, we're at 2/3 pi, or 2 pi over 3. Okay? Add another 1/3 of pi, we're at 3 pi over 3, or pi. Add another 1/3 of pi, we're at 4 pi over 3. Okay? So we're just adding on thirds. Add another 1/3 when we add another 60. So we're at 5/3, or 5 pi over 3. Add another 1/3, we're at 6/3, or 2 pi. Okay? Finally, we're going to do the same thing with 30 degrees. Okay? Remember, 30 is 1/6 of 180, and therefore it makes sense it's 1/6 of pi, or pi over 6. So we're going to add on 6ths of pi. So if we add on another 6th, another 30 degrees, we're at 2/6, or 1/3 of pi. Add another 1/6, we're at 3/6, or 1/2 of pi. 4/6, or 2/3, and then 5/6. And that we haven't filled in, so that's 5 pi over 6. Okay? 6/6 is pi. 7/6, 7 pi over 6. Okay? 8/6 is 4/3. 9/6 is 3/2. 10/6 is 5/3. And 11/6, or 11 pi over 6. And then that brings us back to 12/6, or 2 pi. Okay? So you want to make sure that you filled in your diagram in the same way as mine. You might want to pause at this point to make sure you've filled that completely in before you move on. Okay, I'm going to move this up just a little bit so you can see that. There you go. All right, so you might want to pause at this point to make sure that you've got everything completely as it should be. Okay, so let's look back now and notice that we had talked about the angles that shared the same terminal side. For example, the 225 degree angle and the negative 135 degree angle. Okay, they share the same terminal side, but their rotations are different. So this one was rotating in a positive direction. This one was rotating with a negative direction. Okay, so we're going to define them now as coterminal angles. We'd already talked about that's what they were called, but we'll formally define it now. So angles that have different rotations but share the same terminal side. And of course, they share the same initial side too, always the positive x-axis. Okay? So to find coterminal angles, All we need to do is add or subtract multiples of 360 degrees or 2 pi radians, okay? So let's see how that happens, okay? So for example, let's just look back for a moment at what we were talking about. So if we compare, for example, the 225 degree angle and the negative 135 degree angle, if I add 360 to negative 135, I'll get 225. If I subtract 360 from 225, I'll get negative 135. So adding or subtracting 360 gives us coterminal angles. And I could do that an infinite number of times. So for any given angle, we have an infinite number of coterminal angles by adding or subtracting multiples of 360, or in the case of radians, multiples of 2 pi. Okay? So let's see here, for example, for this 420 degree angle. We're going to find one positive and one negative angle that's coterminal with each of these angles. Okay, now, in order to do this, I don't need to draw this, but I'm going to just to visualize it. But all you really need to do to find coterminal angles is just add and subtract 360. So if I subtract 360, for example, 420 minus 60 gives us 60 degrees, okay? If I subtract 360 again, I'll get negative 300 degrees, okay? So for example, this is just example of two angles that are coterminal with 420 are 60 degrees and negative 300 degrees. And I could keep going. For example, if I subtracted 360 again, I'd get negative 660, okay? If I added 360, I'd get 780 degrees. And again, I could keep going and I'd get even larger degrees that would be coterminal. It's just a matter of rotating more times around, okay? Now, because I know that 420 is coterminal with 60, I could technically just draw a 60 degree angle. And the reason I drew it there, of course, is because we know that the initial side of the angle is on the x-axis, and here's the terminal side of the angle. Now, how do I get 420 around that? Well, if I rotate 360, but then I continue to rotate another 60 degrees, now I've got theta equals 420, right? But of course, that's coterminal with theta equals theta equals 60, because if I start just at that initial side and I just go one little rotation from here to here instead of around once plus here, I'm getting to the same spot, okay? And similarly, for example, if I were going around in the other direction, for negative 300, if I had started here and I traveled clockwise 300 degrees, I'd be at negative 300 degrees. The rotation would be different, but I'd end up at the same spot. Okay, so to find one positive and one negative angle that are coterminal with the angle, I found those two values right here. Okay, all right, so negative 120. Do the same thing. Okay, I could get an angle that's more negative, so subtract 360, and I'll get negative 480 degrees. Okay, or if I wanted to, I could say negative 120 plus 360, and I'd get 240 degrees. Either way, these angles are coterminal with negative 120 degrees. Okay, and again, I can draw negative 120. I can remember that basically here I'm going negative 90, and I'll label this for those of you that might need to see that. 0, negative 90, negative 180, negative 270, negative 360, right? And so here, the reason I'm getting negative 120 here is I've got 90 degrees plus another 30, right? So here's the negative 120 degrees. And that's theta equals negative 120, right? But it's, of course, the same, for example, as 240, right? 180 plus 60 gives me 240, okay? Now, when you're dealing with trying to find coterminal angles in radians, you need to add and subtract 2 pi. And so I'm going to zoom in on this a little so we can see it a little better. You end up having to add and subtract fractions, okay? Now, some people don't like doing that, and they prefer to change this angle in radians to degrees and then add and subtract 360. You can do that, but the key is you have to end in radians. So if we started in radians, you have to end in radians. So if you choose to change this angle to degrees and you add and subtract 360, after you've gotten your coterminal angles, you have to change back to radians, and that's tedious. So my preference is to just add and subtract 2 pi. Okay, so for example, if I were to subtract 2 pi, okay, keep in mind, this is a fraction. This is 17/6, okay? So it's as if we're just subtracting 17/6 minus 2, all right? And the pi's just kind of hang on to the fractions. So if you recognize how to subtract 17/6 minus 2, you know that 2 can be written over 1. The LCD here is 6, right? And so you're really just saying 17/6 pi minus, you know that if I change 1 to 6, I'm multiplying by 6, so I need to change 2 times 6 to 12. Right? So 2 is the same as 12/6. And so then I'm just saying 17/6 minus 12/6 equals 5/6, but I've just got the pi attached. So it's 5/6 pi, or 5 pi over 6. So one coterminal angle in radians is 5 pi over 6. Okay? And that gives me a positive measurement here, because you notice that 17/6 was 2 5/6 pi, so that was over 2 pi. So when I subtracted 2 pi here, I got one positive angle. I could have added 2 pi, I could have added 12/6 and gotten 29/6 pi as a coterminal angle, but I chose to subtract, okay? Reason being, because now if I take that 5 pi over 6, and I subtract 2 pi, then I'll get the negative angle that I'm looking for, because 5 pi over 6 minus 12 pi over 6 gives me negative 7 pi over 6. Okay? Now, practicing here, drawing the angle in standard position is what I'm really doing, because honestly, to be able to find coterminal angles when you're doing this in your assignment, you don't need to draw the angle in standard position. So I'm really just drawing it here to visualize it, to help us understand what the angle is. But you don't have to draw it to answer the question that we're asking you about coterminal angles. Okay, so keep in mind here, we've got 17 pi over 6. 17/6 is 2 5/6, right? So it's 2 5/6 pi, okay? Or another way of looking at it, if it's easier for you, let me just move this over so you can see it better. 2 pi plus 5/6 pi, right? So when you're drawing the rotation here, you're going around in the positive direction, so counterclockwise, 2 pi plus 5/6 of the way across to pi. So to here, okay? And so here's the angle right here, okay? And you notice, I've done this enough. I'm showing you that when I do these, I don't label the axes every time. But if it helps you to do that, go ahead and label it. 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? If it helps you to label, go ahead and label, okay? but this was theta equals 17 pi over 6. Okay, all right. And so last one here in terms of coterminal angles, we've got negative pi over 12. Okay, so if you were going to label, you would label in the negative direction. So you'd have 0 radians, negative pi radians. This would be negative pi over 2 radians, and this would be negative 3 pi over 2 radians. Okay, so in terms of finding the coterminal angles, let's do that first. Okay, so we can add and subtract 2 pi. So if we add 2 pi, remember you can write that 2 over 1. Right? So you've got negative pi over 12. Now in terms of twelfths here, 1 times 12 is 12, 2 times 12 is 24, because the LCD here is 12, right? 24 twelfths is 2. You've got negative pi over here. So 24 minus 1 is going to be 23. So we've got 23 pi over 12. Okay, so that's our positive radian coterminal angle. Okay, I could also subtract. So I can say negative pi over 12 minus 2 pi, or negative pi over 12 minus 24 twelfths pi, or 24 pi over 12. And that's going to give me negative 25 pi over 12. Okay, so there are my coterminal angles. Okay, now as far as drawing this, okay, keep in mind you're saying negative pi over 12 is the same as negative 1/12 pi, right? Negative 1/12 of pi. So you're going, rotating clockwise 1/12 of the way across to pi. So it's going to be very small, right? Because a 1/12 of the way across is going to be 1/6 of the way down to negative pi over 2. And so it's basically, you've got somewhere maybe around here, right? And your rotation, of course, is make sure you have that arrow there rotating clockwise. So that's the theta that we're looking at. Okay? All right, so we're going to be continuing now. We're going to look at the last topic in this section, which is going to be reference angles. Okay? So reference angles are going to be acute, positive angles formed by the terminal side of the angle, theta, and the x-axis. Okay, now generally, remember this is called theta. This is a Greek letter, theta. Okay, this reference angle we generally call the reference angle alpha. Okay, so we'll use alpha for the reference angles. Okay, so what do we mean by a reference angle? Well, for example, in quadrant 1, if I have an angle that has a terminal side in quadrant 1, okay, and of course its initial side is on the positive x-axis, and here's the rotation, okay, here's theta, alpha would be the exact same value as theta, okay? Because you notice reference angles are going to be acute and positive, okay? So obviously this angle here is acute and it's positive. We're rotating in a positive direction, okay? However, let's look, for example, if we were to have the terminal side of the angle in the second quadrant, in quadrant 2, okay? So in quadrant 2, if I were to rotate counterclockwise, there's theta, okay? Now theta is not the same value as alpha, okay? So we can highlight this. So here, if I highlight alpha in yellow, okay? When I highlight alpha here, okay? Here's alpha, because remember, it's the acute positive angle formed by the terminal side of the angle in red here and the x-axis, okay? We don't want this angle because this is obviously an obtuse angle. Theta is an obtuse angle here. On the other hand, over here, we have alpha, and that is an acute angle, and we're going to consider the positive. So for example, let's say that this angle was 135 degrees. Let's say theta was 135, okay? Then alpha would be 45 because the entire distance across here is 180 degrees, okay? Or pi radians. So if we were figuring out what alpha was, you would just basically take 180, subtract the value of theta, and that would give you what alpha was, okay? Let's look at the terminal side of the angle being in quadrant 3, okay? So here you can see you have an angle that is somewhere between 180 and 270, because here's 180, and here's pi, right? So the reference angle is going to be right here, okay? It's the angle formed by the terminal side of the angle and the x-axis. And so that reference angle here would be alpha, okay? And finally here with quadrant 4, if I had, for example, an angle with a terminal side here in quadrant 4. Let me just mark the initial side here on both of these, and I'll do the same here, okay? So theta, starting here and going around, there's theta, okay? And here was theta for this one. But alpha is here because alpha is formed by the terminal side of the angle theta and the x-axis. And we're always going to consider it an acute and positive. Okay? So for example, in this situation, this might be a 360 degree angle theta, and this might be 30 degrees for the angle alpha. Okay? Now, the purpose of this that we'll see more of in section 7.3 is to help us find sine, cosine, and tangent of the angles on the unit circle. So for example, we're going to right off the top of our head know the sine, cosine, and tangent of angles like 30, 45, 60 degrees. So if we can figure out what the reference angles are, for example, if I knew that this was a 30-degree angle right here, and I knew that the sine of 30 degrees is the square root of 3/2, then I'd be able to, or actually I should say the correct value would be the sine of 30 degrees would be 1/2. But if I knew that, then I'd be able to figure out that the sine of 330 degrees is -1/2 because it's in quadrant 4. But we're going to be learning about that more when we get to the section 7.3, where we're going to be looking at calculating sine, cosine, and tangent of angles on the unit circle. Okay? All right, so let's find the reference angle theta for each angle in standard position. Okay, we're going to be looking at some angles that are in degrees and some that are in radians. And then for the last example, example 7 shortly, we're going to be for a given angle in standard position, we'll find the reference angle. okay? All right. Or vice versa, sorry, I misspoke. And for example 7, we're going to be given a reference angle, and we're going to find the angle in standard position. Okay, here we're going to find the reference angle, and we're going to be given the angle in standard position. Okay, so let's look at for 345 degrees, for example. Okay, so I'm going to label this. So we've got 0 degrees here, which when we wrap around the circle will be also 360, 90, 180, 270. Okay, and so if I want to travel 345 degrees, I'm almost traveling all the way around the circle, not quite. Okay, so if I were to travel 345 degrees, I'm traveling to about here. Okay, and then I will draw the terminal side of the angle here. Okay, now if I want the reference angle alpha, that's this angle in here. Okay, so think about for a moment before I tell you. We know that this theta is 345 degrees. If I traveled all the way around the circle, I would be at 360. So think about before I tell you, how can I figure out what this measurement of this angle is in here? Okay, what's the measurement of this reference angle? Okay, and what you should be thinking is, oh, well, obviously, if I travel all the way around, I've traveled 360, but I can take away the distance I've already traveled to figure out what's left. And so what's left is 15 degrees. Therefore, alpha has to be 15 degrees. Okay, that's the reference angle. Okay. Okay, let's look at 5 pi over 6. Okay, so let's label this in terms of radians. So we've got 0 or 2 pi. Here's pi. Here's pi over 2. Here's 3 pi over 2, right? And so 5/6 pi, we're going to travel 5/6 of the way across to pi. Okay. Whoops. I drew all the way across here, and I meant to just draw here. Okay, so right here, here's my angle right there. Okay, and so there's the terminal side of the angle, and theta is equal to 5 pi over 6. And so what's left over here is alpha. So this is just a little bit of, subtraction the same way we did over here, right? So if we say pi minus 5 pi over 6, well, obviously pi is the same as 6 pi over 6. If you just put that over 1, put pi over 1, common denominator is 6. 1 times 6 is 6, and multiply pi by 6 as well. So 6 pi over 6 minus 5 pi over 6 gives us pi over 6. Okay? Okay, so the reference angle there is going to be pi over 6. Okay, now I want you to notice something here. If this is 5 pi over 6, the reference angle turned out to be pi over 6. So let's just notice that for the moment. Okay. All right, so now let's look at theta equals negative 135. Now, of course, as usual, I always say, if you want, pause, work ahead, see if you can figure out what the reference angle is, and then check it. Okay. Now, with this negative here, I want to remind you, when we're finding the reference angles are always positive. Okay, and also acute. Okay, so even though this is a negative value, we're going to get a positive value for the reference angle. Okay, so I'll say 0 and negative 180 and negative 90 and negative 270 and negative 135. And we did this one before, one similar to it anyway, traveling negative 90 and a negative 45. So if I travel here 90, and then, if you're not sure how much farther you need to go, you can do what we did before, right? 135 minus, we've already traveled 90, we have 45 degrees left, okay? So we travel here, we stop, and here is the terminal side of the angle. So we have theta equals negative 135. But remember, you want to be really, really careful here, okay? So what we just did is we just figured out that this angle right here is 45 degrees, right? So from here to here is 45 degrees, right? But you want to be really careful. That, to be specific, is not the reference angle, okay? The reference angle is the angle formed by the terminal side of the angle and the x-axis, okay? So, of course, if this is 45 and from here to here is 90, 90 minus 45 is going to give us 45 right here as well. But you have to be careful. It's not always going to work that way, because imagine if this was 30, then this angle would be 60. So remember, when we're looking for a reference angle, it's always formed by the terminal side of the angle and the x-axis, not by the terminal side of the angle and the y-axis. In this case, they happen to be the same, but they're not always going to be the same, okay? Like, for example, over here, the reference angle was 15. If I had calculated this angle here between the terminal side of the angle and the y-axis, that would have been 75, which would not have been the reference angle, because 75 and 15 is 90. So you have to be really careful that you pick the angle formed by the terminal side of the angle and the x-axis, okay? Over here, it was the same thing. It was the terminal side of the angle and the x-axis, okay? Let's look at 580 degrees, okay? So here we can see this is over 360. So 0, we're going to travel around a full 360 plus some more, 90, 180, 270, okay? So I'm going to wrap around here. So I'm going to go a full 360 around, and I have to figure out how much farther I need to go to get to 580, right? So you might want to take 580, subtract the 360 you've already traveled, so you have 220 degrees left, okay? So if I were to travel 220, here's 180, right? Now, if you wanted, you could subtract the 180 I just traveled. So we have 40 degrees left. Okay, so now travel another 40 out of the distance from here to here, which is 90. So you're landing around here. Okay, and now we're going to draw the terminal side of that angle. And so by doing that subtraction, we've already actually figured out alpha. Alpha is the distance between the terminal side of the angle, right, and the x-axis. And so that is 40 degrees. Okay, so alpha here is 40 degrees. Okay, and by the way, you notice by subtracting 360 here, this 220 was also a coterminal angle with 580, just going back to what we'd done on the prior page, right? Okay, so 2 more of these, and then we're going to work backwards the other way. Okay, so we've got 8 pi over 3 here. So to figure that out, let's label. We've got 0, and of course 2 pi, pi over 2, pi, 3 pi over 2. Okay, so now to figure this one out, 8 pi over 3 is going to be the same as 8/3 is the same as 2 and 2/3 pi, or 2 pi and another 2/3 of pi. Okay, so in other words, we're going to travel around the circle once and another 2/3 of the way to pi. Okay, so 2/3 of the way to pi. So actually, let me just bring it back just a little bit. There we go. That's a little better. Okay. So if I were to draw the terminal side here, okay, basically what I'm saying now is that the reference angle is going to be this angle here, right? Now, if I've already gone 2/3 of the way, I have 1/3 of the way left to get to pi. Now, I could do it with the subtraction like I did up here, but hopefully we can figure it out mentally, right? Instead of having to say pi minus 2/3 is 1/3, hopefully we can just figure out that alpha has to be 1/3 pi, or pi over 3, okay? Okay, now notice here, okay? You notice how we got a result of pi over 3, and this is a multiple of pi over 3, 8 pi over 3, okay? So let's look back up here at B. You notice we got pi over 6 for our answer, and that the original theta was a multiple of pi over 6, okay? Now this doesn't work with all denominators, but with the main denominators that we're going to work with, the key that you want to keep in mind is that if your denominator is 6, the reference angle is going to be pi over 6. If your denominator is 3, the reference angle is going to be pi over 3. Okay, same for multiples of 4. So for example, if I had 5 pi over 4 for theta, the reference angle is going to be pi over 4. Okay, and it doesn't matter if it were negative. I could make this negative. It doesn't matter. The same thing is always going to happen. So with denominators that we're going to be focusing on, of 4, 3, and 6, when you're looking for reference angles, you actually can get it right from the value of the denominator. You'll easily come up with the reference angle. So it's easier actually to find reference angles in radians than it is in degrees. Okay, so for example, now that we look at part E, using that knowledge, you should be able to easily know that the reference angle is, think for a moment, you don't have to think that much. You know that the reference angle is going to be pi over 6, okay? And just to verify it here, this is negative 2 1/6 pi, or negative 2 pi plus another negative pi over 6, right? So if I were going to rotate, here's 0 and negative 2 pi, negative pi, negative pi over 2, negative 3 pi over 2. So if I were to travel negative 2 pi, and then another 1/6 of pi, just to right here, sure enough, you would see that if I traveled 1/6 of pi right here, then alpha obviously has to be pi over 6, okay? Even though theta was negative, of course, alpha is always going to be positive, okay? All right, so let's work backwards here. We're going to find angles in standard position. So we're going to find an angle in standard position theta for each reference angle, okay? So for example here, this reference angle is 10 degrees, okay? So let's try this first in each one of these quadrants. So in quadrant 1, okay? So alpha equals 10 degrees, and we know that I could literally just say then that theta is equal to 10 degrees as well, right? Or I'm just going to kind of give you some other examples if I wanted to. For example, let's say I were to rotate around once and then land at this terminal side. I have 360 plus another 10 degrees. So by adding 360 to 10 degrees, I get a coterminal angle. So I could say another possible value of theta for that reference angle might be 370 degrees, right? These are just examples, okay? I can have an infinite number of theta values because there's an infinite number of coterminal angles with that 10-degree angle, right? So if I wanted to, for example, I could subtract 360, go the other way. So for example, if I were rotating clockwise instead of counterclockwise, right? And I landed here, I would be at theta equals negative 350. Okay. Now I'm not going to do this for every one of these. For the others, we'll just do one example of what theta would be for the given alpha. But just to kind of give you an idea that really you have an infinite number of answers, because for every reference angle, there's an infinite number of coterminal angles. Okay. In quadrant 2, here's the reference angle, alpha equals 10 degrees, okay? So if you think about what that theta would have to be, really simple, right? You could just say 180 minus 10, and so theta would equal 170 degrees, okay? Over here, in quadrant 3, reference angle of 10 degrees. It has to be, again, that reference angle we know is here and not here, because it's always formed by the terminal side of the angle and the x-axis, right? So all of these, here's the reference angle right here, okay? So if I want to figure out an angle for that, you know, I could either say 180 plus 10, say, for example, 190 degrees, or I could go the other direction, right? I could say theta equals negative 170. Again, this is just an example, and this was just an example, okay? And here, alpha equals 10 degrees. I could go around, I could travel around, and I could say 360 minus 10, and theta then would equal 350 degrees. And again, just an example, okay? So if you'd like, you know, you could go ahead and practice, do these on your own. Pause this and do these on your own, but I'm going to continue here. I just did that 10-degree angle. On this page, I want to look specifically at the acute angles 30, 45, and 60, because these are the reference angles that we're going to be focusing on when we're looking for sine, cosine, and tangent of these angles in section 7.3. So I wanted to focus on 30, 45, and 60, okay? So again, 30 degrees is equivalent to pi over 6 radians, okay? So when we look in quadrant 1, the reference angle for 30 degrees, here's alpha equals 30, okay? And again, I can pick whatever, give me a theta value, whatever I want by adding or subtracting 360, but I'm just going to go with the simple one here. We can say that theta is also 30 degrees, okay? Looking in quadrant 2, here's 30-degree angle in quadrant 2. Alpha equals 30 degrees. Again, I'm going to go with the simple one here. I'm going to say theta is equal to 180 minus 30, so theta is 150 degrees, okay? And that would be theta right here. In fact, let me draw the arrow for this one as well, okay? All right, in quadrant 3, if we draw an alpha in quadrant 3, which is right here, 30 degrees. Again, I'm going to just do some positive angles here. Okay, so again, I can add 180 plus 30 here, and I can get that theta is equal to 210 degrees. And again, I could have done negative 150. Remember, 210 plus the absolute value of negative 150 210 plus 150 is 360, as we would expect. Okay. And finally, in quadrant 4, here's the 30-degree angle. Here is alpha equals 30 degrees. And I could say 30, let me just see, because I didn't know if you could see the same. I got a notification on my screen. I want to make sure you didn't see it. So if we take the wrapping around the circle, we can just say 360 minus 30, and that'll give us that theta equals 330 degrees. Okay? So notice, all we're doing here, we're being given a reference angle and we're finding corresponding value of theta. Okay, I could have made negative values. I could have added and subtracted 360 to find coterminal values. I just went with the simplest positive value here. Okay. For 45 degrees, okay, 45 degrees being pi over 4, actually. I see there's a typo here. So this should say pi over 4. On your version, it's going to say pi over 4. I'll make sure to change that. So for pi over 4, we're going to have 45 degrees. And so here's the terminal side of that angle here. Alpha equals 45 degrees. And of course, I could say that theta is equal to 45 degrees as well. Okay? Okay, so that's in quadrant 1. So in quadrant 2, here we go, right here. Again, I could use either a negative value or a positive value. It doesn't matter. I'm just going to go with the simple positive value here. So if this is alpha is 45 degrees right here, I can just subtract. So I can say that 180 minus 45 degrees gives me 135, right? So theta is going to equal 135. Okay? And in quadrant 3, and I bet most of you could probably do this on your own at this point, but I'm just doing these for extra examples, especially since we're not in the classroom. Okay, so we've got alpha equals 45 degrees right here. And I can add 180 plus 45. That'll give me 225, right? So theta equals 225 degrees. Okay, and finally in quadrant 4, we've got right here alpha equals 45 degrees. Okay, and that 45 degrees we can rotate around here, and if I take 360 and I subtract 45 degrees, I will get 315 degrees for theta. Okay? So you can see here, for all of these situations, it's just a matter of simple subtraction that can give us the value of theta for a given value of alpha. Okay? All right, so last one here. Alpha equals 60 degrees, which is in radians, pi over 3. Okay? So again, what we're going to do is draw alpha. So here's the 60 degrees in the first quadrant. So alpha equals 60. Okay, and of course, because it's in the first quadrant, theta is equal to alpha. Now, again, like I can have a coterminal angle with that. 360 plus 360, 420 would be also a theta that would have that reference angle. Or 60 minus 360, negative 300 would be a theta value with that would have that same reference angle. This is just an example. Okay? And this is the rotation if it were theta equals 60. Okay? In quadrant 2, with a reference angle of 60, we'd be about here. And to get theta, the simplest theta possible here, we can just say 180 minus 60 is 120, right? So theta here is going to be 120 degrees, okay? In quadrant 3, here's the alpha. So alpha equals 60, okay? And again, just add 180 plus 60 gives us 240, which means that theta is equal to 240 degrees. Okay? And last but not least, in quadrant 4, here is alpha is 60. Okay? And so wrapping around, I can just say 360 minus 60 gives me 300 degrees for theta. Okay? All right, so that will do it for lesson 7-2. Have a good day, everybody.